Welcome back to ETCS Bites Back. And in this edition, I'm going to have a look at baseline 4. Now, I know it's been out for a little while, but it's taken me some time to fully get to grips with what all the changes are. I'm still not sure I understand everything in it, and there are some things which are quite interesting. Anyway, so let's have a look at baseline 4. Well, before we start, we need to just clarify what is a baseline. Well, it's defined in subset 23 as a stable kernel, and that covers the system functionality, its performance, and other non-functional characteristics. One of the key things is that the functionality and features are defined within the baseline, within the subsets, and they are the ones which are possible at that baseline. Not every feature or every bit of functionality has to be implemented in either the onboard or track side, although an onboard that doesn't implement functionality would not be classified as interoperable because there would be restrictions on its location of operation. The key thing is the baseline defines the language at the interface between the onboard and the track side. It may also include interfaces with other components of the ETCS system. But in order to maintain compatibility, that language needs to be clearly understood so that both the onboard and track side can communicate clearly and safely. And a baseline is not required to be compatible with other baselines. It can introduce changes to the language, functions can be removed or added, and other areas can change. What's a release? Well, a release is defined as a specific set of Annex A documents. Now, Annex A to the TSI, or in the UK, the NTSN, is a list of those specifications, the subset principally, which are relevant to a particular version of ETCS. And a release implements a baseline. Within a baseline, there are different releases, or can be different releases, and each of those are compatible. A train operating with one release within a baseline is by definition compatible with a train, an onboard, a trackside of a different release, but within that same baseline. The releases may have some different functionality, so some things may not work in that situation, but broadly, the system will not fall over. So I mentioned system version. What's it for? Well, it defines the mandatory functions to ensure the technical interoperability between the track and the train. So it's a method of the onboard and trackside checking that they're compatible with each other, and it can be used to adjust the behavior of both of them so that they can increase that compatibility. It is used to get compatibility within a baseline between the releases, and also for systems of different baselines to adjust their behavior. So how do they decide what goes into a release and what goes into a baseline? Well, generally, releases will not add new significant functionality or features. They concentrate mainly on errors, things which need correcting, things which have been omitted, or things which need clarifying. Wherever possible, a baseline is avoided since it is a significant change to the system. If it can be managed through release, then that is an advantage. However, there are things, often known as game changers, where the baseline has to be invoked, and this will provide, through enhancements, a significant change in functionality. Things that are introduced as part of this process will not be available for earlier baselines. A baseline change is required if the enhancements are not considered compatible. And that's typically where they require a change to an existing message or packet, or a key piece of the functionality. Every time somebody identifies something that ought to be changed within ETCS, then it goes through a process where it is classified. Is it an error? in which case it could be managed through the release process, or is it an enhancement? And if it is an enhancement, will it be compatible? And if it is not compatible, which applies to probably the majority of enhancements, then it has to wait until a baseline change is proposed. And in the interest of stability of the system, baselines are only introduced when there is a significant quantity of changes which need, on the basis of commercial or safety pressures, to be implemented. So what is all about backwards compatibility? Well, the first thing to remember is that the trackside works to one baseline and one release. However, just to confuse, it may use packets and messages for different releases, and even in some situations for different baselines. The onboard has a maximum release it can work to. That's the latest version of the baseline and the releases within it that the onboard is configured to work with. And so it'll work with any trackside up to that release, including potentially lower baselines. If the onboard encounters something which relates to a higher release, but within it's at the same baseline, it will just ignore the information. But if it does encounter something for a later baseline, that will generally cause an error. When an onboard has to work with a lower release or a lower baseline, if I can refer to them as lower, then the core functionality of the onboard doesn't change. However, what the onboard does is adjust how it processes messages received from the trackside and sent to the trackside. What that means is that if, for instance, in baseline 3 release 2, the DMI format has been updated compared to baseline 3 MR1, then a train operating on a baseline 3 MR1 trackside will still display a DMI looking like a baseline 3 release 2, because that is the baseline and release of the onboard. So baseline 4, it's out. It's been out for a little while. It took quite a while to get to conclusion, and various areas are still under development. But what's in it? Well, lots of error corrections. Up until the start of baseline 3 deployments, most of the specifications were largely theoretical or based on supplier products. With baseline 3, there was a drive from the railways, that's the operators and the infrastructure managers, to improve the functionality of ETCS, and also to improve the consistency of behavior between different products. This led to lots of applications of ETCS outside its core area, which was originally high-speed lines and metro services. When one starts introducing mixed traffic, freight or cargo with passenger trains, different types of complexity of layout, stations, yards, etc., then you discover that there is areas of functionality which are, one can argue, wrong, or certainly ambiguous in how they should be interpreted, which means that different suppliers could produce different answers, are poorly defined, again, leading to the potential of incompatibilities, undefined, it just got forgotten or missed out, or generally could be improved. And this goes around things like brake models, information about speed restrictions, the impact of confidence limits, etc., a number of areas. However, it is a baseline, so we would expect to see a number of enhancements, and these are things which can't be implemented just as an add-on to existing baseline 3, although more of that in a moment. The first key enhancement was to move towards automatic driving, a new mode, AD, which supports ATO over ETCS. That doesn't mean that ATO hasn't been deployed with ETCS or indeed with other safety systems. But the ATO that has been deployed has been supplier specific. The alternative to ETCS is CBTC, and that is generally a supplier defined system, and that will often include an ATO functionality. And that ATO functionality was generally around uniform types of trains operating on uniform lines. But ATO over ETCS supports multiple types of trains, freight and passenger, operating on the whole of the ETCS network, with the ETCS automatic train protection functionality behind it. The next enhancement was to address an issue around shunting. Now, shunting is a difficult thing in most countries. Train formations get changed. The driving cab and the locomotive is often not at the front of the formation. So a movement authority, FS or OS, would not be available. Many railway administrations recognised that the use of SH, shunt mode, was not the safest and had a number of challenges. A workshop was held in Brussels by the user group, probably now about 10 years ago, where shunting was considered in detail. And it was recognised that ideally one would want to be able to supervise the remote end of the train when you're shunting, so that it couldn't exceed the limit of the shunting area and perhaps go on to another running line. And the facilities such as dangerous shunt didn't really address the issues. After many discussions at all levels in Europe, supervised manoeuvre, originally known as cab anywhere, was the result. And this is a new mode which supports shunting and requires that the whole length of the train is known to the ETCS and the position of the cab within that formation is also known. And we'll look at that in a bit more detail later on. You're probably aware that GSMR, the radio system used for voice and data on an ETCS railway, is obsolete. And in fact, in a few years' time, the frequencies used for it will be reallocated. So a new system is needed, and various people have been looking at using 5G, Wi-Fi, Tetra, and other systems in order to communicate between the onboard and the trackside. And FRMCS, Future Railway Mobile Communication System, is a project to enable that functionality. So within baseline 4, the building blocks have been introduced to enable the ETCS onboard, the kernel, to manage multiple communication streams via a gateway. And that also opens up the opportunity for other systems on the train to also share the same data radio network. Multiple threads or pipes or streams, whatever you like to call them, can be established over the data system. We'll talk about that a little bit more as we go on. And lastly, work has been done over several years within the European organisations on moving block, and a set of specifications were being developed. And it became very clear that level 3, which had been designated for moving block, was actually unnecessary. As far as the onboard was concerned, all its messages and commands from the trackside were identical to those from level 2. There was a little bit of extra information that a train with moving block capability could send back to the trackside. However, it would need to send that back whether it was in level 2 or level 3, or indeed level 0 or NTC when it was being proposed to transition to level 2 or 3. So level 3 has been removed from the specifications. So let's have a look at the system versions. So system version 1.0. This was the first recognized baseline known as baseline 2. Up until that point, each of the suppliers had been developing their own solutions, working collaboratively, so there was a lot of commonality, but there were discrepancies and differences. Europe worked really hard with the ERTMS user group and the suppliers and ERA to bring together a set of specifications. They were first published as subset 26 version 2.3.0. However, there were still anomalies within that, and a set of corrections, subset 108, was published to produce what is known as 2.3.0D, often known as debugged. And that was the only version which was legally available for new deployments until Baseline 3 came along. Now, Baseline 3 was published as system version 2.0, and initially that was subset 26, version 3.3.0. However, before it was actually deployed significantly, it was upgraded to correct a number of outstanding issues and small errors, and was republished as 3.4.0. So nowadays, system version 2.0 refers to subset 26, version 3.4.0, and is often known as maintenance release 1. Now here we begin to see where it can get a little bit confusing, because although the onboard would be upgraded to 3.4.0, tracksides take often a lot longer to upgrade, particularly because all of the onboards need to be at the new baseline before you can change the baseline of the trackside. So in order to provide functionality to support the baseline 3, which has improved performance, a number of optional features were added into the baseline 2 trackside definition. And these are defined in the baseline 3 documentation, so subset 26, 3.4.0, and specifically chapter 6. What happens here is that the baseline 2 trackside is able to transmit packets which are specific to baseline 3 operation. Those will be ignored by a baseline 2 onboard operating on the baseline 2 trackside. Despite the hard work to improve the performance of baseline 3 for maintenance release 1, there were also still some errors discovered which needed to be corrected within the baseline 3 specifications. There were also some opportunities to extend the functionality, and particularly to introduce the option of packet switching for the radio connection. The brake model was improved, as was the DMI specifications, and this was all lumped together into subset 26, 3.6.0, otherwise known as release 2. We now move on to the set of specifications surrounding baseline 4. And if we start at the bottom, system version 3.0 refers to baseline 4 as applied to tracksides and onboards, and is defined in subset 26, version 4.0.0. Similarly to the baseline 3 specs, there are some options which can be applied to a baseline 3 trackside or onboard. System version 2.2 has been introduced to specifically allow the introduction of automatic train operation, both for a baseline 3 onboard operating on a baseline 3 trackside. This is because it was perceived there was a commercial advantage to the industry in being able to introduce ATO without having to upgrade the trackside to baseline 4. Although effectively one is providing baseline 4 functionality on the baseline 3 trackside. And it was also thought that this was an exception to the normal rule where you would be able to upgrade the baseline 3 onboard to support baseline 4 functionality without actually having to include all of the baseline 4 functionality. System version 2.3 is an enhancement to the baseline 3 trackside to support other baseline 4 functionality, including supervised maneuver. So this is very similar to 1.1, where baseline 2 had extra packets and messages in order to support baseline 3 operation. Here we have the ability for a baseline 3 trackside to support baseline 4 onboards. And what's interesting with both 2.2 and 2.3 is the trackside now has to take consideration of the system version of the onboard it is communicating with and adjust its messages or how it interprets received messages in order to take account of the different baselines or releases of the onboard. Now, I think that if one is really strict and you read subset 104, I think it is, which describes forward and backward compatibility, that systems versions 2.2 and 2.3 probably bend or even break the compatibility rules for baselines. And the reason for that is they both require changes to the existing packets and messages. So they affect the language between the onboard and trackside. So if you had an onboard operating at system version 2.2 on a trackside which was operating at 2.1, then you would have different language, and it's arguable that that is not correct. And as I said, they both require both the trackside and onboard to consider adapting the messages and packets that are received and sent. So let's have a look at some of the items in a little bit more detail. FRMCS. FRMCS is the Future Railway Mobile Communication System, unlocking ETCS from GSMR. And not only does it allow multiple transmission mediums to be deployed, but it also allows multiple systems to share the transmission medium. Early on, GSMR operated over circuits or channels, where it was effectively a phone call where data was transmitted as a series of frequencies. It's moved on now to using packets and IP addresses, and it now will move on with FRMCS to being much more like the communications between our computer and servers, with the options of Wi-Fi, 5G, Tetra, and any other communication system you may choose. What this does is removes the detailed control of the radio communications from the ETCS kernel and passes them to a data gateway. However, for legacy systems using GSMR, either GSMR circuit or GSMR packet, the ETCS kernel still needs to have a module which can control them. So we get multiple channels of data, and that can be really useful when we want something like ATO. It enables the data to be shared between ETCS data on one channel and ATO data on another channel. It also enables status information on the condition of the train, etc., to be transmitted back over the same data network. In order for it to be secure, it uses standard IP-based private keys and security layers, backed by certificate authorities. So it's using the best possible security and cyber technologies. So what about automatic train operation? Well, automatic train operation is based on grades of automation. GOA1, grade of automation 1, is about providing advisory information to the driver. The driver remains in full control of the movement of the train. GOA2 still has a driver in the leading cab who checks that the train is safe and secure before selecting start. But from that point on, the train will drive itself to the next stopping location. The driver in the cab may have some role at supervising the movement and observing for staff on the track to sound the horn, etc. However, they don't drive the train in normal operation. GOA3 moves on to not having a driver in the leading cab. A member of train crew, who may be positioned anywhere in the train, undertakes the train checks before the train can depart and selects start. The train will then drive itself to the next stopping location. However, there will be a facility for train crew to intervene or drive in degraded situations. Grade of automation 4 will have no staff on the train. The train preparation and driving are fully automated. So the train will have sensors at doors, etc., to make sure there is nobody trapped. So what do these mean? Well, GOA1 would be often known as a driver advisory system, or DAS. GOA2 is the ATO that's been applied on the Elizabeth line and the Thameslink core lines in the UK, where the driver remains at the front, does the door, closes the doors, checks the train is clear, and then selects start, allowing the train to drive to the next location where it will open the doors automatically. And GOA1 and GOA2 are supported in baseline 4. GOA3 is not supported yet in ETCS, but it would be similar to the Docklands Light Railway in London, where the train manager is positioned in the train. They close the doors, lock the doors, and then select start, but they're not sitting at the front of the train. And GOA4 would be like one of the airport shuttles, perhaps at somewhere like Heathrow. It's rather like a automatic lift. The passengers get in, the doors close after a warning sound. They check the doors. Checking the doors is closed is done automatically, and then the train departs. So how does the ATO system drive the train? Well, it needs similar information to the driver would need. It needs details of the track, which is described as segment profiles. These go from each node to the next node, and they define potential stopping locations, the gradient, speed profiles, and any other information. In addition, the train needs to know the timetable trip that it is on, and this is contained within a journey profile. It provides the timetable for entry into each of the segments on the route as appropriate. It provides the stopping information, stopping times, departure times, and the list of segments that the route will be along. The two of these combine to define when automatic driver may be offered to the driver. There will be times when the driver will need to drive the train because it is not possible for the system to have sufficient information. And also, one will need to consider when automatic driving should end and the driver will need to take back over control. So ETCS retains the safety functionality when ATO is operational. It supervises the speed against the most restrictive speed profile, MRSP. It also supervises ends of authority and supervised location. ATO operation is within a full supervision movement authority. So ATO, GOA2, replaces the driving tasks. It seeks to drive within that ETCS safe envelope. It also will adjust the speeds to meet the timetable needs. It'll manage train stops at stations, opening of doors, and it may offer other functionality such as automatic power transitions. ATO, when it is active, does have some influence on the ETCS model. Some elements of the ETCS brake model are altered. Because one no longer has a human making the decisions, you can remove or reduce some of the human reaction times. So let's move on to supervised maneuver. So up until this point, ETCS has only allowed movements where the train data is known and has been validated, the driver's in the leading vehicle of the formation and in the leading cab of that vehicle, and the direction controller is in the forward position. Up until this point, movements without a movement authority have what is often described as a lower level of supervision. So in order to improve the safety of propelling and shunting movements, where vehicles need to be propelled, so the driver is not at the leading end of the formation, or may even be driving in reverse, then or where shunting activities can't be achieved without selecting reverse, then the existing modes don't support what needs to be done. And so SH mode, or going into level 0, or NTC, is deemed less safe than operating with a movement authority. And this has caused the railway undertakings and infrastructure managers a lot of angst over the years, particularly where an error could occur because the system cannot control an unsafe shunting movement effectively. SM mode effectively allows a movement authority to be sent to an onboard even though that onboard is not at the front and facing forward within the formation. So it allows for movements in both the forwards and reverse directions relative to the driving cab that the driver is within. The supervision is to the ends of the formation rather than the locomotive or traction unit that is housing the ETCS onboard. But it does require that the train length and position within the train of the onboard are assured. And that requires that the train length and position information is obtained automatically rather than relying on driver input. Moving block. Baseline 3, level 3 was defined to enable moving block. And at the time, the specifications had not been fully developed. All was known was that the movement authorities would be based on reported position of trains without the provision of train detection at the trackside. However, having worked through the behavior of a moving block system, all of that behavior for the onboard was almost identical to level 2 and level 3. The movement authorities still looked the same. The only difference was that in the position report from the onboard, there was extra information about the integrity of the train. And that was needed in level 2 as much as it was in level 3 in order to know whether one could enter a level 3 area. So with almost no change and having done all the analysis, then baseline 4 has removed level 3. At one point, as you may have heard, it was going to be called level R for level radio. But after a lot of discussion, a pragmatic approach was taken of retaining level 2 and just deleting level 3 from the specifications. So, what is in baseline 4? Well, it introduces some new capabilities. ATO, supervised movements, maneuvers, and the Future Railway Mobile Communication System, FRMCS. It also introduces a concept which existed but was rather hard to work out how it would work, which is to have a standard set of specifications and rules for reduced envelopes, which will allow implementations to be legal, which only apply some of the functionality. That sort of existed in Chapter 6 of Subset 26, where it described how tracksides and onboards would behave when working with other releases or baselines of the other product. And I think it can be said that forwards and backwards compatibility becomes more interesting. However, I'm still working through the full implications of system versions 2.2 and 2.3 to understand how they will work. It's not easy, and if any of you want to try and work it out, then subset 26, chapter 4 of the baseline 4 specifications is your starting point. So I hope you found that useful introduction to baseline 4, and in later videos I'll be looking at some of the enhancements in more detail.